Now let us see about hybrid pi model, H parameter model, some Ebers Moll form by this formula. This is the formula finding the that is R equal to V by I d here, and the value of both parameters and functions of the current junction, and here these two elements are in parallel with the junction capacitance, which is R, and R is the series resistance between the external external emitter terminal and the internal emitter region, and this resistance is usually very small and may be on the order of 1 to 2 ohm. And here in this second B cell, this shows the equivalent circuit looking into the current terminal, and R is the resistance, is the series resistance between the external and the internal collector connections and the capacitor C. And here this the third frame, and here figure 3, it is the equivalent circuit of the reverse bias B dash C dash junction, and this is the C parameters is the reverse bias junction capacitance, and R is the R and the I reverse bias diffusion resistance. And here, while we are seeing this computer simulator is usually required for the complete model between the because of the large number of elements. Some simplification can be made in order to gain an appreciation of the frequency effect point, and the reverse 2-point network for the H parameter model is shown on the right, and at low and middle band frequency the H parameter models are the real values. Other models exist because this model is not suited for circuit analysis at high frequency. And here, while we are saying the H parameter model is given by this equation, and is given by this equation, and the model of the common emitter configuration or specification sheet is given by this equation. And here E is the emitter for common emitter, and C is the collector for common collector, and B is the base for common base. Here it shows the short circuit input impedance, and second one it shows the open circuit reverse ratio. Next one is the short circuit forward transfer ratio. Next one is the open circuit output impedance. Here next one is the Ebers Moll formula. Here the model is based upon the interacting diode junctions and applicable in any of the transistor operating diodes. The figure shows the current direction and the voltage polarities used in the Ebers Moll formula, and the current are defined as all entering the terminal, so that IE plus IB plus, that is collector current, emitter current, and base current equal to 0, and therefore the collector current can be written in general as IC equal to alpha IF minus IR, where alpha F is the common base current drain in the forward active mode, and in this mode this is the junction, that is IC is given by this formula, and here the current is given by this formula. And here the IB, the base collector junction becomes forward bias such as the saturation, therefore it is given by this formula IR, and using this above formula the current equation can be given, and it is calculated by using this formula. Therefore the current direction and the voltage polarity and the voltage polarity definition for the above Moll model, and this is the basic Ebers Moll model, and this can be written by, and therefore by using this equation that is the formulas can be, it is the collector current, and is given by substituting by appropriate substitution, it is given by this formula. Here only there are three parameters are independent, therefore the reciprocity relationship such as alpha F IES equal to alpha R into IEC, therefore VC is given by using this formula combining the previous same equation, therefore we can write this formula, that is IC can be related by using this formula. Therefore while we are solving and substituting the previous values, we are getting that VBE equal to VT into ln of this numerator divided by denominator, where Vs is the terminal voltage. Similarly we can solve this exponential by substituting in this, therefore after simplification we are getting this equation, and the ratio of ICS to IES can be written in terms of alpha F and alpha R, and finally we are getting this VC saturation by using the Ebers Moll formula. That's about. Thank you.